Good morning or good afternoon. Today we're going to be looking at and taking notes on quadratic functions. So take a minute and press pause. And I want you to pause and write down this model into your notebook. You will be uploading it on here. Okay? So, all right. My definition. So over here, this is what your textbook has for quadratic functions. Definition of a quadratic function. We're going to put this in our own words. A, B, and C are real numbers with A not equal to 0. The function given by fx equal ax squared plus bx plus c is called a quadratic function. Real life data can be modeled by this. This is an example of a rocket or a projectile motion. Anytime you have something that goes up in the air and then down, or anytime something falls with the effect of gravity, it actually follows a quadratic model. The graph makes what's called a U-shaped curve called a parabola. And here we have again real life properties such as satellite dishes or flashlight reflectors. You know, we're going to study these more as the chapter goes on. These are some key words that you guys did your Desmos activity on last night. Axis of symmetry, axis of the parabola, and the vertex. All right, so we're going to take some notes on here. So on your book, in your notebook, you should have quadratic in the center. And then my definition, so for your definition, so a quadratic is a function that can be written in what's called expanded, we're going to call it expanded form. All right, and that expanded form is going to look like, we're going to type it out. Let's put it right here. F of x equals ax. We're going to put a squared plus bx plus c. Okay, I need to write in a 2 here because if I don't write it in, I can't do exponents any other way. So that's my 2. That's a 2. Okay, and the big rule here is that a is not 0. Because if a is 0, then this whole term goes away. And think about it, you just have bx plus c, which would make it linear. Characteristics, we have some graph characteristics. Let's change the color. Let's make it fancy. So some graph characteristics would be 1, the graph is a U-shape called a parabola. Okay? The graph makes a shape that either opens up or opens down. Okay, if that's my graph, either opens up, boom, or opens down. We took some notes on numbers of solutions. Both of those have numbers of solutions. It can be written in what's called 3 different ways. It can be in expanded form. Okay, it can be written in what's called a vertex form. Okay, or it can be written in what's called written in either form. We're going to call it an intercept form. Okay, 3 different ways it can be written. So the expanded form version would look like the one over here. Okay, where you have fx equals ax squared plus bx plus c. The vertex form is going to look like this. F of x equals a, x minus h. There's going to be a 2 up top plus k. I want to write that 2 up there because that's important. And I might actually go back and change that. Oh man, where's my equal sign? Where's my equal sign, baby? Man. Edit. Equals. Okay, and then we have what's called, see now it's all jacked up because 2's in the wrong spot. Let's move it. Let's put that 2 up in the, it's right outside. It's the exponent on the parenthesis. And then intercept form might look like f of x, and that looks so baby small. All right, let's make it a little bigger. F of x equals x minus a, x minus b, where those 2 numbers are your intercepts. A and B are your intercepts. That's called intercept form. So some example equations might look like, let's do our expanded form equation. And that might look like, I'm going to try to write with my mouse here. That might look like f, no I'm not. That's hideous. Let's not try that. So f of x equal to, let's say 4x squared plus 1.2 x minus 5. It's okay if, you know, I wonder if I can, I feel like this is a thing. I'll have to look that up later. I know it's a thing where I can actually, I think I can put exponents on here. So 4x squared plus 12x plus 5. It's okay that there's a decimal. It would also be okay if it was a fraction. What else do we have? I'm going to move this and get rid of it. Okay, we have vertex form, so that might look like f of x. Whoop. Where's my edit? You guys see where it says edit? It doesn't. That might look like f of x equal to maybe like a negative 3x minus 10 squared plus 5. Okay, and there's a 2 up outside that exponent. I have to draw it in because that's just where I'm at with this technology here. And then our vertex form might be like f of x equal to x minus 4 and then like x plus 6, something like that. Maybe, okay? All right, that would tell us our vertex. So some non-examples. Let's look at some graphs first. We might see a graph that has a curve, but it's just a curve going up. That's exponential, or maybe it's a line. That's not it. Maybe it makes like a squiggle shape. That's not it. Or maybe it doesn't make a U, it makes a V for an absolute value. Okay? Another non-example might be a linear equation, f of x equals 5x plus 3. That might be a non-example. Another non-example might be a cubic. F of x equals x to the third plus 2x squared plus 1. Yes, it has a 2 in the exponent, but there's also a 3. This would actually make it another type of function. Okay? I want you guys to copy this down into your notes and upload a picture of your model into your notebook on this page, okay, for your notes for today. All right, guys? That's what we got.